Okay, so the last time we were here, we were talking about cin, and we were able to read input from the user, and you had to specify where you would put that input, which is a certain variable. But what I didn't cover was the actual character variable input, which is a little bit more complicated, and I wanted to explain it a little bit further so you understand how character variables work. Last time we were here, I did explain the declarations of different variable types, and there's many variable types on your book. If you look on page, I think it's in chapter 1, you can see all the types of variables that you can declare. So I went over the ones that we're going to be using, which are int, char, float, and double. And then last time also I went over the typedef data type. So what I want to do now is I want to talk a little bit about string character input and string character variables, which have the base data type as char. And I told you last time that when you declare a char, a character string array, and you have your variable, you dictate a size. For example, this size of 50, that means that I can store 50 characters in my character variable array. This isn't representative of that, but I did show you an example of this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes, right? And if I change that so that we can match up to our example. The other thing, one thing that I didn't go over is that with character arrays, you have to take into consideration that you always have to have a character, you have to have space for the last character in a character array. Because what C++ does and it needs to know is, when does a string end? For example, if I declared cmake, right, and it had 10 bytes, I need to realize that whatever I'm going to put into that variable has to be 9 bytes long plus something called a null character. The null character tells the C++ compiler that the actual string is done, so that when you're doing any type of manipulation with strings, the compiler will know that this string ends at that null character for that variable. For example, let me take this out. We'll just work with this. You know what? We're going to create a new file. Well, actually, you know what? We'll just take all this out. Let's take this out. You can copy that later from. Take this out so that I don't confuse you. Okay. And I'm going to have the user enter a name. Then I'm going to have him enter some string text. Okay. What happens is when you prompt the user to cin any type of input into a character string array, you have to consider that the max input type that he could enter are 9 bytes, because the 10th byte has to be saved for the null character. So, for example, basically, if I enter a name and I put in my name AL, and then E, and then X, automatically this last byte will be the null character, because this, I'm sorry, let's just go back. Automatically, it'll insert the null character at the end of this string. Okay, and that's fine because I have enough room for other bytes. But if you're gonna fit more than 8 bytes, you know that your max is 9 bytes, and then you need one more byte for the actual null terminator. That's what it's called. It's called the null terminator of a string character. And this is only for character strings. Anytime that you're declaring a char character string array, you always have to know, you have to make room for the null terminator. And let me just make a note here. Last byte is for the null terminator. And that's important to realize whenever you're reading input from the user, because you have to have enough room for whatever you need to read in, plus that last byte that the user has to enter. For example, if you're reading in a state, a two-letter state, then I'd have to do a 3-byte array, 2 bytes for the state, and then one last byte for the null character. So for example, if I was reading in New Jersey, I'd say N, J, and then this would be the null terminator. And this would be just blank. And use space. Right? Now I made my array 3 bytes. And with arrays, with character arrays, or any type of arrays in C++, the index where you start at, or the position when you start at, is always 0. So for example, if you go in here, this would be the 0th position, this would be the 1 position, and this would be the 2nd position. So for the first 2 positions you have enough bytes, but then I also need the 3rd byte, or what we call in C++, the lingo is the index at 2, or index 2, to have the null character terminator. And let's read a state. So I would say enter state name, right? So if I execute this, compile and run, then I can do nj. Nothing's going to happen because I haven't printed anything out. But if I was going to print out this state name, then I would say the user entered, and then I would do C make. Okay, then let me print this out. So I would do nj, and then the user entered nj, right? Because that's what I entered into this character array. Now, if you wanted to see what position is at 0, because remember, I was telling you that every time that you do create a character array, you can access each index location by its index. If I wanted to access the letter N, then I can just say cmake of subscript 0, and then it would give me whatever value is at 0. So let me try that, and I'll do nj, and then there you go. The user entered N, right? Because I'm referring to the index as 0. So what do you think would be if I do cmake of 1? Did you get it? Right, it would be J. Because if I do that, and I compile and run, I'm entering in J, and then that would be J. Now if you've been listening, what if I do 2? 2 would be, if you look at the array, size of 3, but at index 2, right, you're going to get the null terminator. So if we do that, compile and run, I do nj, that blank is really the null terminator that you're seeing there. It's not a viewable character, but it's there. Okay. Now, one of the problems that you run into with CN and entering characters into CN is that the space is ignored. For example, let's turn this back into a 20 size character array, right? So enter your name, and then I'll do that, right? And then I'll do cout you entered. I compile and run this. I'm going to enter my name, but there's going to be a problem here because cin ignores white space. As you're going to see here, when I do enter, it only read up to the space. And what cin does is it says, okay, I encounter a space, so now I'm ready to read in whatever I read up to that space and store it in your variable. So now you've lost the rest of your input. So the problem is that cin will skip any type of space, tab, or even a new line, and it'll terminate at that point, because again, that's a delimiter for cin. Okay, The way to get around this problem is you use something called cin.getLine. GetLine will grab the whole line and it'll store it into the variable that you want with the space included. For example, if I enter, you say please enter a name, instead of doing cin make, you just use cin.getLine, and then you pass in your variable. And then something different here, which I'll explain in a bit. Let me explain this a little bit. So cin.getLine is a way to get the whole line, and telling the compiler to use this. This is something called a function. It's called a getLine function. And with this getLine function, there's two parameters. First parameter is your variable, and the second parameter is how much you want to read into your variable. Now, the second parameter is something new that you probably never, I will guarantee that you've never seen before, is a function called size of. Size of takes the size of your variable and returns the size. So this size of will return a 20 because you've allocated 20 bytes, right? But you only want to do 19 because you want to read up to the 19th byte. Okay? So what's going to happen is, because of the null character, right? You're really only reading into the 19th byte. The null character will be at the 19th byte. Because it's a 0th index, and the way this getLine function works, you got to go from 0 to 19, which are 20 bytes. This will return 20, and you don't want to do 20, just 20. You want to do 19 because you want to store the first input into the 0th index, the second input into the first index, and so on. So you're always one size behind, so that's why you always have to subtract it by 1 when you use this function. So what this will enable us to do is read in white space. There's a syntax error here. Size of name. Oh, I'm missing a parentheses here. And then I will do compile and run. So now if I enter my name, so what's going to happen here? I've blocked the input at cin.getLine. It's waiting for my input. It's going to take the size of. It's going to read up to all the size of 19 bytes because size of CMake is 20. But again, you're not, with arrays in C++, you're not going up to the 20th byte. You're going up to the 19th because you start at 0. So you go from 0 to 19. Okay, and that's why you're doing that -1. Take that. That's your max size that you're going to read up to, and the variable is CMake. So if I press enter, now it reads the actual white space. Now, another problem lies when you mix a cin and a cin.getLine, and I'm going to explain that in a little bit right now. Let me just write you an example. So for example, let's say I had two, I'll do an int I number 1, right? So I'm going to say cout enter a number, and cin I number 1. And then cout enter your name. You entered number. And you entered the name. Okay. Let me compile this. So what it's prompting me to do is it's prompting me to enter a number, and then it's prompting me to enter my name. And then it should print out the number I entered and the name that I entered. But it's not going to act as you expect. So watch this. So if I enter a number, 55, right? I'm expecting to enter my name, but what happened is now I got enter your name, which is this part right over here, and I was expecting it to block a get line, but it didn't block a get line. It just kind of fell through, and then it's going to say you entered the number 55, which is what I entered, but then because it skipped out, there's no value for CMake. So what happened here? The problem lies that cin ignores white space, it ignores new lines, and it ignores tabs. When I enter the 55 and I press enter, cin is a world of buffers, and C++ is really a world of buffers. When you enter input using the cin function, it's going to grab the input 55 and store it into iNumber. But there is a buffer in memory that is used by cin to keep track of the input. So for example, let's look at something new here, and I'm going to put a new page. Let's do insert blank page. Okay, let's go in here. I'm going to insert a table here. Okay, and we'll just put I'm just putting an arbitrary size, and we're going to call this the cin buffer. So what happened was the first input that it asked me for was integer, and that's okay. And my keystrokes were 5 and 5, right? So let's do that again. Compile and run. So I enter 5. So when I enter that 5, what's happening is in the cin buffer, and this is different from your character array variable, okay? I just want to make that distinction. Now we're talking about the cin buffer used for input. The cin buffer now received a number 5, okay? And then I enter another 5, and this goes into another box, okay? So right now the cin buffer has 55, okay? When I press enter, there is going to be an enter key that's going to show up in my cin buffer. When I press the enter key, okay, at this point in the game, 55 was placed into my integer variable called iNumber. So iNumber equals 55, right? So we can say take this out, it left the buffer, but your buffer, because the cin ignores any white space or any tabs or new lines, it doesn't get rid of this enter in the buffer. And the problem with that is now you have a dangling enter in your cin buffer. When it gets to the point of reading in the get line uses the new line character, or the enter key, as a delimiter to read in, to stop reading in input. As a consequence, when it gets to that point, the dangling enter is already in the buffer. It's going to clear it, and it didn't read any input yet. Hence, it doesn't ask you for more input, because the thing with getLine is it reads up to the new line, takes the new line out, and done. Hence, I can't really enter any input. The way to solve this is by using cin and getting rid of that white space to get it to clear the buffer. And it's simple. The thing that I do is right before the get line, so that I clear in any dangling enters, I just do white space. Okay, and the WS, just give me 1 second while I look this up. It's not the white space, but it reads away the any character white space or end line in the buffer. This might be incorrect, but let's try it, because it might be the new line. So if I read in 55, there you go. So now it's prompting me to enter my name, because the WS gets rid of any leading characters in my buffer. So it got rid of that enter that was in there. It does not stand for white space. It's just to read in the next character from the buffer. So now that I can enter my name, I can enter Alex Louie and problem solved. So I've been able to mix cin and cin.getLine, whereas before I wasn't able to mix it. I had to, the only way to get around this is using that cin ws, so that we get rid of that dangling enter in the cin buffer. So in summary, again, when you read from cin, you're going to have a cin, something called a cin buffer, which keeps track of what you've actually entered in through the keyboard. Once you press enter, whatever input you've entered in will go into your variable, which in this case it went into I number 1 and treats it as an integer. But because cin ignores any white space, new line, or tabs, that dangling enter is still in the buffer. And once you start using the get line is going to use the new line to tell it, okay, stop reading from input because you've reached a new line. And that was our previous problem. It got to the new line even before it prompted me for input. The way to get around this is we use a cin, get rid of any white space, and the enter in the buffer is pretty much considered white space, but it's really an enter key, and it'll get rid of that in the buffer, and now I can read in my input using my get line. Okay, if you have any questions regarding this, and we're going to have an assignment that mixes this, please let me know and I can clarify a little bit further. So let me put a pause here so I can move on to the next topic. Okay, let's talk about the output manipulation that we want to do. Now, we saw that this was some type of input manipulation using the WS, which will get rid of that white space, which is considered any enter that you enter in is pretty much white space, but it's still an enter key. But we really haven't touched upon how to format any output. And let me give you an example of what we can do. In your book, on page 111, gives you a couple of good examples on how to output. I'm going to go over them, and we'll go over them together. One of them is we've gone over already, which is the end line, which gives you a new line after each output statement. And the other one that we need to touch upon is a set width, which is a set W. Now, in order for me to use a set width, I have to include my library called iomanip.h. So iomanip. Okay. So that I can use a set width manipulator. So let's do the following. Let's do int number 1 is equal to 2097. I number 2 is equal to 5. I number 3 is equal to 837. And I would say I'm just going to print these out. Do that. Do that. I'll print number 4 is equal to 394. 7, 6 is equal to 1623. So if I print these out, do 6, 5, and 4. if I print these out, you see how they're not lined up correctly. Well, let me put a space in there so that you see. So I'll put a space in here, space in here, space in here, and a space in here. So now, let me see this. See how these aren't lined up correctly? So the 7 is over here and the 5 is up here. These aren't lined up correctly, and this is a little bit off. I mean, it's a little lined up, but they're very uneven. So the way that you would do this is you would use a set width manipulator so that everyone takes a set amount of characters for each variable. For example, if I do set width of 5, and I do set width of 5. So what this is going to do is it's going to take this variable, whatever value it is, and it's going to tag on 5 spaces on to the value. If there's already a value that takes up any amount of spaces within that 5, then it'll subtract it and will give you the amount of space remaining in your output. And let me give you an example. If I run this, right, do you see what happened there? There's a leading space, and that's 1, and then this 2097 is 4, so 4 plus 1 will give you 5. Same thing here. There's a leading space, 2 spaces, because this has 3 characters in it, so 5 minus 3 will give you 2, and that's how many leading spaces you'll have so that these line up. And if I do it for each one, so I'll do set width 5, set width 5, set width 5, and then set width 5 here. This is going to do for every number, it's going to give us the 5 spaces that we need so that they perfectly line up with each other. If I execute, compile, and run, you see that? This has 4 leading spaces and the 1, which is the 5. This also has the 4 leading spaces, which is the 1 and the 5. This has 2 leading spaces. For A37 has 3, 5 minus 3 is 2, and then this has 4 characters already and has 1 leading space because 5 minus 4 will give you 1. And this set width will give you a good way to format your output so that you don't have to play with putting in spaces and trying to line everything up together. It's a very powerful tool when you're trying to write output and to the user so that it formats correctly. What I suggest you do is try a little bit of the exercises in the book. If you look at page 112 in the book, create that program yourself and see how you can line it up and add and subtract any type of positioning. And try doing it with another number in set width. Instead of doing 5, do 6 or do 7, and you see how it reacts. Okay, the next output manipulator that I want to go over is the setprecision, which is a very important manipulator because that has to do with the double any type of decimal numbers. So let's try that. We'll just put in our comments setprecision, and then over here I'm going to put, sorry, this is set width. Over here we'll put set precision. Okay. What we're going to do is we're going to declare a couple of variables here. Set precision here. So I'm going to declare number D number 1 is equal to 132.364, and then D number 2 and say 26.91. And what I want to do is I want to figure out a way to format these numbers using 2 decimal points, 3 decimal points, and so on. So what the set precision does, it cuts your floating point numbers into whatever precision that you want to use. And again, you're going to use a set precision manipulator. And let me give you an example. For example, if I do cout D number 1, we can take these out of the way. Without any precision, setting any precision, then I can compile and run, and you're going to see the number 132.364, right? But now what I want to do is I want to set the precision to be 3, and what the compiler is going to do is it's going to cut your number with the decimal point included. So let me show you how that looks. Okay, so what happened here is first it looks at what your whole number is. Your whole number is 132. Okay, I've set my precision to use 3, so it starts with the whole number. It says, okay, I'm going to count the number of the number of characters are in my whole number. So there's 3, so I'm going to cut the rest. So if I did 4, then it would include the 132.3. So if I did that, and then did compile and run, 132.3. Well, what happens also here is that it's going to round, and you have to be careful with these precisions, because if it's going to cut it, it's also going to round it. So you also have to be careful with that. Now, if I did set precision of 5, okay, so I did that. So it's going to do the .36 now, because it's not going to round to 6, because again, this is 4, so it won't round up. But generally, what's going to happen is it's going to round up, or it's going to stay the same. It seems that it doesn't round down. So you have to be careful with this set precision manipulator. So you saw there that I did 5, so it took the whole number and then whatever characters are remaining, so 2. Now you're asking, well, what would happen if you do under 3? Because would it cut the whole number? And the answer is no, because if you did 2, it's going to ignore it. It's not going to do any of this. It's just going to write out the number. So if I try and write this out, let me do that. Okay, it's going to do some funky stuff like that, but it's going to completely ignore what you're trying to say. It's not going to cut your number. Okay, so if I do set precision of 4, and then I compile this, again, you do the 3 whole numbers and then whatever number is after, and then it's going to round it. So you have to be careful. So why don't you try the exercise and try doing the number, and what happens if I do set precision 3? So if I do something like that, and I expect you to be following along by writing the code with me. I do day number 2, right? What this is going to do is just going to give me 26.9. So compile and run. Oops, let me put a space in here. And I can mix these now. So I can say set width. Let's do a 5 field width. Same thing here. I'll do a 5 field width. and then I'll do set width, and you see the 26.9. Okay, sorry about that. And so if I run this and I compile and run, it doesn't look like it did 5 spaces, 5 characters, but it did. So if you count the number of characters within 132.4, you're going to have 5. So the field of 5 is going to be a field of 5. 4, so that's 1, 2, 3, 4, 5. And then this one will give you also 5 with the leading space, right? So you have 1, the decimal point, 2, 3, 4, 5. If I change this to 6, maybe you'll see a better difference. And I compile and run. So now you have 2 leading spaces here, and then you have 1 leading space because it's 1, 2, 3, 4, 5, 6 with a space. And then here you have 2 spaces plus the 4 characters, which is 6. So that's the way set precision works. And it's going to set the precision based on the whole number. It's not going to set it on a decimal, but it's going to set it on the whole number. So if I do set precision of 3, it's going to return 132. 4, well, it's going to turn 132.4 because it rounds up based on the next digit. And again, it does from left to right. And if it's less than the whole number amount, it's just going to give you some weird garbage. It's really pretty much going to ignore it and not do anything. So you have to make sure that whatever precision you want, if you want a 5 or 6 digit number, and I wanted a decimal points, and I do 132.36, and I would do a set precision of 5. But you also have to be careful, because what if you want to do some type of money output, and then you have 2 in here, and you've done a precision of 5, right? 1, 2, 3, 4, 5. But now you have this extra one, so you're really going to go up to here, right? So let me show you. Let me give you an example. So if you do 5, right, then your number increased by 1, right, on the thousands place. Now 5 is going to take this 4 plus this 1, and it's not going to give you the second digit. Okay, and there's a solution for that, which I'm going to show you on the next little lesson that we're going to go over. Give me 1 minute. Which is called a show point manipulator. First, if I was going to do something like this, so let's declare another number. We'll do the number 3. That's equal to 123.4, right? By default, it's not going to show you the leading zeros after the 4. If I run this, do execute, compile and run, see 123.4, and what if I need 123.40? Well, what you have to do is you got to use something called show point. So if I do show point, and I do execute, compile and run, it's going to do 123.400. The problem with this is it's going to tag on the default of set precision is 6. So what's going to happen if you don't mix and you don't identify what type of precision you want, it's going to default to 6 precision. So if I do set precision of 5, right? Because I do set precision of 5, now the default is overwritten, so I'm going to get 123.40. To compile and run, So I get 123.40. Okay. Now, the other thing that I wanted to show you is there's types of notations that you can display in C++. One of them is called the fixed notation, and the fixed notation is going to give you just that, a fixed notation with the decimal points right after the number. So if I do 123.4 and I mix the fixed in here, versus the scientific notation, which is going to give me the E, the E notation, 10 times -1 or -2 to the 7th power or something like that. So there you go. When I do the fixed notation, okay, it's going to pad on the zeros to the end, which is not really something I want, because the fixed notation, what it does is it's going to pad on the zeros at the end and ignore whatever I set initially. So this one and this one are contradictory of each other. So I've set the precision to 5, but then once I do the fixed notation, the fixed notation does is it extends my number by padding the zeros at the end. And I don't want to do that. I want to take that out and leave the precision at what I said, at 5. Okay. Now, the one that you want probably is the one that's called show point. So if I do the number 4 equals 120. Okay. So if I display this one, the number 4, let me take this one out, and I do compile and run, right, it's just going to display 120. Okay. But what I want to do is I want to show the decimal point. So if I do show point and treat this, so it's going to say set precision, it's going to show the decimal point, and it's going to give me the amount, okay, which is the padded zeros at the end. So it's going to pad, as a default, it's going to pad the 3 zeros at the end. Now the thing is with these output manipulators is C++ is very difficult to pinpoint output in general, so you have to play with these yourself to get to the precision that you want. So usually, for example, if I were to do this, once I combine this one with fixed, okay, and I misspoke earlier, you should use these to combine. You should combine them. Not so. What happened earlier was I mixed them, but because I had forgotten how they work, now I remember now. So when you mix the set precision with fixed, then now you're doing the right decimal point precision only, because you're using fixed notation. So you do want to mix these together, and this will allow you to now have 2 decimal point numbers. So now I have 2 places in my decimal point because I use fixed and I use a precision of 3. So if I increase this to 3, right? I'm sorry, precision of 2. If I increase this to 3, then it's going to tag on 3 decimal places. See that? So 400. By combining this with fixed, now it's only going to look at the right side. It's only going to look at the right side for my precision. If I take the fixed out, then it's going to look at the whole number. And that's something that I really don't want to do. I want to only look at the right side so that you can cut the numbers on the right side by 2. So if I was going to do this for D number 1, I'm going to do precision of 2 so that I get back 2132.36. So let me do that. So I compile and run. So there it is. So 2132.36. So that's how you would cut your number into 2 decimal places. And by combining with fixed and set precision 2, you are combining them using 2 decimal places. And again, you're only looking at the right side. I apologize earlier for telling you not to mix these. You should mix these, and this will get you where you want to be, because most of the problems that we'll be dealing with here would be with money, and you usually just want 2 decimal places. But you can play with this yourself and mix these output manipulators so that you have an idea of how they work. The thing with this is that you have to do it yourself. You can't just rely on doing one example and that's it. You have to keep playing with it, and that's what the programming assignments are for. Okay, and that's pretty much it for the output manipulators. If you look at chapter 3 in formatting output, there's others that you can play with. You can left justify output, right justify output, but you can try those yourself in the book. Let me pause here for a second until I get the right notes out for the style guidelines, and then I'll get back to you in a bit. Okay, let's resume. The style guidelines for this class is, as you've seen from the programs that I've written, and we'll go over these real quick because I don't want to waste too much time on them. You can read them on yourself. Is not that strict, but again, it's not to give you a hard time. It's just so you write cleaner and more readable code. The first style guideline is make sure that you always put your name and date and the description of your program up here. So basically, what I taught you initially, you put a comment, and then you can write in your name, the date, and description of the program. So that's the first thing. The second thing is, when you're creating your variables, make sure that they're all lowercase, and make sure that they're descriptive. Don't just put something like int I or int x. These are okay if you're using a loop control variable, which we have not gotten there yet. But for now, until further notice, make sure that they are descriptive, like I've been doing. For example, I number 1, I number 2. If something's an average, declare it as an average, the whole name. Make sure that if you're going to do 2 words in a variable name, like employee name, make sure they do have an underscore so that it looks a lot neater than just putting it all in one word. Okay. Make sure that you don't mix case in your variable names. Make sure they're all lowercase. All variables should be lowercase. All of them. All of them. Should always use lowercase for all variables. Okay. Also, when you declare anything, obviously you have to use lowercase, int, double. The only time you should be using uppercase is if you use const or any type of type defs, as I've done here before. So if I declare a const variable, so const int pi, right, 3.14, and actually that's a wrong example. I should do const double. Okay, see, this is uppercase. Or if I do const int size equals 50, so I can use this size as my size of my array, character array. But I know that from reading your code, if something is in uppercase, then I know that it's a const variable. Anything else that's lowercase, then I know that it's just a normal variable. And then obviously the other one that is not included in the sheet is if you are using chars or ints or doubles, and as we get through the strings, string array, a string variable type, then prefix it with the variable, your variable with the type. For example, number 1 has I underscore and then number 1. Okay. Function names, we won't get to that because we're not going to read writing functions in this particular class. And as I said before, use concise, meaningful, unambiguous prompts for all requests for interactive user input. So as you've seen here before, whenever I wanted to prompt somebody for input, I usually put a cout statement before it and said, please enter 5 numbers, or please enter this, or please enter that. So make sure you do that. And make sure that you use the manipulators except with set precision fixed for your output as we've done here, so that you have more clean, readable output in your code. If you are using any type of formulas, as here, make sure that you leave a blank between the equal signs and your variable. So if I do average equals total points divided by points times 10, these two variables and this division sign are separated by a space. Everything is pretty much separated by space. So this is not well formatted as you write it out, but this is because there's a space in between each variable. Okay. When you do multiple declarations in your program, make sure that you put a comma in between each, just like I've done here. So when I did I number 1, I initialize it here, and then I put a comma and a space. Comma and a space. Here, comma and a space. Okay. Try and omit needlessly blank lines. So if I'm doing something like that, try and, you can put a blank line here, but I don't want to see a program that looks like that. It's not well written. It's not well coded. It's hard to read. So try and get rid of as many spaces as you can. Okay. Use proper indentation. So I don't want to see something over here where you do something like that, right? I don't want to see that. Everything should be indented at least with 1 tab. So please try and keep the indentation all together. Okay. And then once we're using files, okay, make sure that when you don't open a file unless it's going to be used, or before it is used, until it is used, and always close the file as soon as possible. So those are just a bunch of tips that I have, and to make sure that I don't want to take off points or anything that looks very, very messy. Because that's one of my pet peeves is when I'm reading your code, again, keep in consideration that I'm reading 20 or 30 programs for only your class, and if I have to try and decipher what you've been trying to write, I'm just going to get frustrated and say, okay, I'm just going to mark this wrong because I do not understand what he's trying to do. I don't know what these variables mean, so I'm just going to take off points. Okay, so please follow this, read these guidelines. If you have any questions on the guidelines, you can always ask me or write me, or we can have a call, and I can discuss them with you. If you need me to take a look at your program, just so I can see how you're writing it and you're telling me if there's anything that's out of whack, I can comment on it and tell you, no, this looks out of whack, or try and use this for your variable names. Okay? So that's that. That's all about style guidelines. Now, the other thing I want to introduce to you in this week is file streams. So we're going to start using file streams, which will use some primitive commands to read and write from a file. And after that, we will use these later on for our programs when you're writing programs. Okay? So there's 2 ways that you can read and write it to a file. You can use the ifstream object, which is to read in from a file, and then there's the offstream object, which is to read out to a file. And it's very, very easy to use. And this is all on chapter 5. And we'll start with writing to a file. So let me get rid of this. Okay. And for us to write to a file, we have to use the include fstream library. Okay. Now the notes say that you can use a fstream object, which we won't be using because that's for binary files. Okay, we're going to be using just the ifstream and the offstream in this course. So we'll concentrate on that. And again, you need to use the fstream library up here, so don't forget to include that. And this, again, I remind you, the IOMAN IP is for manipulation of output. The one we used for the set width, set precision, and the other types of fixed endpoint and all that stuff. And then the fstream is for the file. So real quick, I can get you started on writing and reading from files. So if I do offstream out, declare my offstream object, and it's pretty similar to writing to cout, except that you got to do a couple of steps before. So if I do offstream out, and then I have to open my file, so I do out.open, and I'm just going to call it test.txt, and then I'm going to write out my output. First test file, and I can use the output manipulators in here using my output file stream. Okay, and then the one thing that you want to do is once you write to you're done writing to your file, you close the file. So out.close, and we're good. So if I execute this, nothing is going to show up to the console because I haven't written anything out to output, to cout, but I have written to test.txt, and where that's located is, if you go into your computer under devcpp, okay, it's always going to write it out under your devcpp folder because that's where your executable files are. So if I open this out, first test file, if I look at my code, so it's under program files, just devcpp, test file is written out there. Okay. I can also write more stuff in here, and again, this is much like your cout manipulator. Hello world. And if I did execute, let me kill this. So nothing's going to be written out here, but then when I look at my file over here, then I say first test file, hello world. Now why is that space there? Because I put a space in between my quote and the H. The new line is the end line, and then there should be an end line here, so you see that the cursor is over here, right? So pretty much nothing changes except now instead of writing out to the black box, now I'm writing out to the file, and that's the only difference. You can treat this as a cout where you're writing out to a file instead of writing out to a black box. Now, what if I wanted to read from a file? Very, very simple. So what I'm going to do is, after I close my file that I've written out to, before here I'm going to declare an ifstream object. Now I'm going to read in from my ifstream object. But I need to point to the file that I'm reading from. So what I do is I say in.open, and I'm going to say test.txt, which is the file that we created. And same thing, you can treat this as a cin object. So when you're reading input from the user using cin, you need to declare some variables to read them into. Same thing with your in object, ifstream object. So what I'm going to do here is I'm going to declare char c first line, right? And I'm going to say this is going to be let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I need 17 characters, right? Because I need 16 for the text and then the 17th character for my null terminator. And if I do in with my extraction operator, first line, and then I can say I'm going to write out to the console, okay, because now I'm writing out to the console. I can say the following was read from my file. Alright. So let's do that. Let's do project, execute, compile, and run. So you see that the following was read from my file first. You're having the same problem here that we did with the cin. Because I put a space after first, it's skipping that space. So very, very simple solution. Just like you have cin.getLine, then you should have in.getLine from your input, right? Which is true. So what we're gonna do is we're gonna try it. So we're gonna say in.getLine, and then we'll do the same thing. Size of C first line -1. Put these in parentheses. And this should work. Not, I'll have to look up the command. So let's compile first. So that works. So now I can read in the whole space, the whole line, and I can say execute, compile, and run. See that? First test file. Why? Because I used, instead of cin.getLine, now I'm using my variable name. This can change. So I can say in file, and I can say out file. Right? But now this has to change. So I gotta say out file, out file, out file, out file. This is in file, in file. Okay. And using my in file variable, I use the getLine function just like I did my cin. The cin was predefined, but here I defined my own using the ifstream object. And then I said in file.getLine, read it into my variable called first line, which has 17 bytes, 0 to 16, and the 0 to 15 will go into that, and then the last character, obviously for the null terminator, read that in using that. And this is the size of it. So if I compile and run, and I do that, right? And then same thing, if I want to read the next line, I gotta read in the white space, because that dangling enter is still gonna appear after the file, right? Because I wrote out the end line afterwards. What I need you to do is, after you're done viewing these lessons, look at chapter 5 for 5.11, using files for data storage. Go over those examples. Okay, read that section, and then also go over the examples that I went over for set width, set, and all that stuff. And that would be for chapter 3, chapter 3 for the cin object, and go over the notes. And all the readings are in Moodle. So if you go over here, it says read from our book, page 68 to 73. So read those pages so that you are familiar with some of the stuff that I've gone over here today. So you know about consts and all the other data types, and obviously I've gone over this whole section of lesson. And obviously do the assignment here. I'm going to post a solution after maybe sometime next week, but I'd like you to try it first, and then you can do the programming assignment on your own, and then you'll have a quiz. Okay? So that's it for this week, and I will post a video next week of the next topics, which will involve operators, math operators, more fun stuff using the actual operator lists and terminology and all that. So I will see you next week. If you do have any questions, please ask, and maybe we can set something up. And please try the examples in the book. It's very, very useful. The book is very useful. Try and look at the book. Read the sections in the chapter. And if you need the exact pages, please let me know, and then I'll probably post them up on Moodle if they're not already there. And please do the examples, and you should be fine. Thanks.